Thanks a lot. Yeah, thanks everyone for coming. Hopefully we'll get through this fast so we can all go and party. But my name's Adnan.
I'm Nolan, and we're both contributors to the Velero project.
And we're going to talk about CSI and specifically the Volume Snapshots API. So we'll take a look at CSI, or the Container Storage Interface, and then we'll have a look at what that specifically means for Kubernetes, and Nolan will walk through the workflow of using that, as well as a demo. And then we'll wrap around at the end and take a look at what's next for CSI. So Kubernetes has come a long way since its inception in how it manages stateful applications. We have stable APIs now, so we have things like stateful sets, which allow us to orchestrate stateful applications. And then on the storage side, we have, since 1.6, we have dynamic provisioning using persistent volume claim and persistent volume APIs. And we can do so across multiple different storage providers using the storage class abstraction. So Kubernetes supports multiple different storage providers, and you can see in this table from the documentation some of the ones that are supported. You see the usual suspects, so AWS EBS, Azure Disk, GCP Persistent Disk, but you also see things like Cinder, Ceph, NFS, Gluster, and Portworx, and a few other storage providers as well. One thing you'll notice from this list is that not all of these provisioners are actually in the core Kubernetes code base. And this is possible because Kubernetes has an external storage interface that allows storage providers to essentially implement a plugin and keep that plugin outside of core and manage the lifecycle of that plugin outside of core. This is great because it allows storage providers to iterate independently of the Kubernetes lifecycle and reduces the support and maintenance burden inside Kubernetes core. And so some of the plugins here, you can see Gluster and NFS, and a few of those are in this external storage repository. So this is great. We have a way to support multiple different storage providers, dynamically provision volumes. But storage doesn't just stop at provisioning. When we care about complex stateful applications, we also care about the ability to snapshot volumes, clone volumes, restore, resize, and a few other operations. And specifically, snapshot and cloning and restore give us the framework to perform backup and disaster recovery, which is really vital for running production systems in Kubernetes. Luckily, we have a great ecosystem, and this is just a few of the tools that are used for backup and disaster recovery inside of Kubernetes. Each of these tools have different strategies for actually performing backup and restore in Kubernetes. Some of them may call out to the storage provider APIs directly. So for example, a tool could call out to the AWS API to take a snapshot of an EBS volume, and then on restore, call out to the AWS API again to restore that snapshot. Others may use a file system level snapshot tool, such as something like Restic. But this has performance implications for large volumes. And in order to interface with different storage providers, some of these plugins have some of these tools have plugin architectures that allow storage providers to implement a connection to the tool. So that means we have orchestrators that need to connect to storage and tools that need to connect to storage. And for each of these, a storage provider needs to implement a separate plugin and maintain that plugin and keep it up to date and in feature parity. That's a lot of work for storage providers. Wouldn't it be nice if a storage provider could just implement one interface and have that used by each orchestration system and each tool? This is where the container storage interface comes in. So it's a community-led effort. The communities of Kubernetes, Mesosphere, Mesos, Docker Swarm, and Cloud Foundry came together to support the container storage interface and come up with a standard specification and gRPC API for interfacing with storage. So this is what that gRPC looks like, and it's probably too small for you to see. But it essentially gives us the capability to provision volumes, manage snapshots, and resize volumes using this one interface. So as a storage provider, I can now implement one plugin and have it work everywhere. So let's take a look at what CSI means specifically for Kubernetes. So in SIG storage, they're trying to move out all the storage providers that are currently in tree to outside the core code base by Q4 next year. A big push for this is going to be embracing CSI as the primary storage integration. In order to connect to CSI, the Kubernetes API is going to have some storage APIs to interact with these CSI drivers, and we'll take a look at those in a second. I'll pass it on to Nolan now.
Sure. So I'm going to look at how we specifically use the volume snapshot portions of the CSI API for provisioning, attaching, detaching. That's all GA in Kubernetes, but for volume snapshotting, that's only just now getting to beta in 1.17, and it was alpha from 1.12 to 1.16. So we're going to look at some of the alpha data structures and workflows. For some of my diagrams, I just wanted to show some of my conventions. These solid lines are going to be data relationships, so linkages between CRDs and references, and this dashed line is going to be when code's acting on things. Okay, so first we're going to just look at a cluster, and we're going to zoom in really closely and look at a PVC, a persistent volume claim, pointing to a persistent volume to a volume. This is kind of your basic storage scenario. You would then have a pod pointing to that PVC so that you can actually get to your file or your block or whatever you're using that for. To actually take a snapshot of that, you would submit this volume snapshot custom resource definition. This is namespaced. It's going to be in the same namespace as a persistent volume claim, as you can see down there in the spec. And you're pointing it at whatever persistent volume claim you want to make a snapshot of. So your cluster is going to look a little bit like this after you make that submission. You have added a volume snapshot that makes a reference to that persistent volume claim, and through that has a path to the volume. Then you have this CSI Snapshotter, which is a generic controller that is written by the SIG storage community and is common to all the implementations that issues a create gRPC, a create snapshot gRPC method call to whatever your provider is. It calls that driver, and that provider driver will create the snapshot for you. And while that snapshot is being created, the controller is going to update your volume snapshot to be from having ready to use nil to ready to use false. And then it's going to get the snapshot handle, which is some snapshot ID, whatever scheme your storage provider uses. That will be returned back to the CSI Snapshotter controller, and that will be put into a volume snapshot content object. Then you have the provider's driver monitoring that snapshot, looking to see for whatever state the provider needs to judge that snapshot is ready to use for restoration. Once it's ready, it's going to tell the CSI Snapshotter that, hey, you can use this, and then that will get passed into the volume snapshot, and the user can then use that volume snapshot for restoration or cloning. So I mentioned the volume snapshot. This is a cluster scoped resource, so it's outside of the namespace, and this is pointing to the actual snapshot contents on disk. So you can see I've got highlighted there the snapshot handle. In this particular case, this is a snapshot on AWS. You also have a reference to the persistent volume that you created the snapshot from, and you have a pointer to the volume snapshot that kicked it off. And also note that, again, this is the alpha version of the data structure. The definition has changed a little bit with the beta versions, and there's also a status for this now. Okay, so once your volume snapshot is ready to use, you'll notice down here at the bottom you've got a creation time and that you've got ready to use set to true. And also up in the spec, you have a snapshot content name pointing to the ID of a snapshot content object. Well, I'm sorry, a volume snapshot content object. And this is a diagram of what your cluster is going to look like. So up at the top, you have the normal storage you're probably used to. And at the bottom, in the bottom left, you have the volume snapshot, which is referencing the original PVC, which has a bidirectional relationship with the volume snapshot content, which is then tying together everything to the snapshot and the persistent volume. So to restore or make a copy even, you would create a new persistent volume claim with this new data source field, which is now beta as of Kubernetes 1.17 and was alpha from 1.12 to 1.16. This data source field will point to a volume snapshot in the same namespace as the persistent volume claim. And this will use the snapshot as the source for provisioning a new persistent volume. So if we look at the restore process, the diagram's very similar, but some of the arrows are pointing in a different direction. So in this case, we still have the volume snapshot with its bidirectional relationship with the volume snapshot content, but we now have a PVC pointing to the volume snapshot instead of the other way around. So now when we reconcile state on restore or copying, we have the CSI provisioner controller, again, a common controller written by the SIG storage community. This is going to watch for a persistent volume claim that has a data source. It's going to create the PV, and then it's going to ask the provider's driver to create the volume. The provider's driver will then give the volume ID to the CSI provisioner so it can update the PV with that information. And once that volume ID is added to the PV, it can point to the volume. And then we end up with a state, again, that looks pretty similar to what we looked at before, but in this case, we have a persistent volume claim that actually has a data source field pointing at a volume snapshot. And then finally, one piece of data that I didn't go over is the volume snapshot class custom resource definition. This is very similar to a storage class. This holds fields such as the snapshotter, which is going to be your provider driver that does the work. It's also going to hold the parameters that are key value pairs to give to your driver. And this will vary based on your driver or plugin. And it also holds the deletion policy for your snapshots, which is to retain the snapshots beyond the life of your Kubernetes objects, or to delete your snapshots when the Kubernetes objects are deleted. And both the volume snapshot and the volume snapshot content objects will point to your volume snapshot class. So now let's take a look at the demo. Thank you. I pre-recorded this just in case the Wi-Fi was unreliable. So I set this up with the kind of standard WordPress and MySQL demo. I populated the site with a post, also customized the name of the site. We have a comment, and I also leave a comment here, just so we can show we have data in here. And we're also going to move over to a console, and we're going to take a look at the namespace. So we can see in here we have pods for WordPress and MySQL. And we also have persistent volume claims for both of those. And here we're just looking at volume snapshots for both of those. So you can see we have one, they're both in the same namespace, and we have one each for the persistent volume claims in the same document. Go ahead and apply that. And then we'll show that it was updated to ready to use false. And then after a little bit of waiting, if we run the same command, it will be actually ready to use. So now we're going to take a look at what's in a volume snapshot contents. So we can see here we've got a snapshot handle, and again, this is from AWS. In this case, I've set them up to be retained beyond the life of my Kubernetes objects. It's pointing to my persistent volume, and I have a reference to my volume snapshot. So now we're going to delete the namespace. Now, something I'm going to mention here is the volume snapshots are namespaced, so those are going to go away. The volume snapshot content object is not namespaced, so we can still get to our data, but we're going to need to recreate the volume snapshot. So we are going to do that, but we're going to delete the namespace here. And I'm going to show we can't get to WordPress anymore. And I actually have the code for this example up on GitHub if you want to see how some of this got wired together. This particular part isn't shown in the demo, but if we look inside of our restore contents, you can see here I have the name of the volume snapshot content objects already populated into my file. And this is an area that higher level tools can help with. So Velero builds on this with our CSI snapshotting plugin. And then one more thing we have to do is the relationship between a volume snapshot content object and a volume snapshot is bidirectional. So we have to make sure that we're not pointing to the old ones. So don't do this in production, but, but we're going to delete the UIDs of those very specific objects so that we're binding to the names, not the actual object. This has changed a little bit in the beta versions of the CRDs so that you don't have to mess with the spec as much. But in the alpha versions, this is one thing that we found you might have to do if you run into an issue where you deleted the namespace and you need to recreate a volume snapshot pointing to the volume snapshot content. And just to show you the data source, in this example, this file is basically just a copy of the original setup files that I used, but I edited it to have the persistent volume claim use a data source pointing to the volume snapshot. And so when we apply that, you can see the volume snapshots were applied before the persistent volume claims because they need to reference, the persistent volume claims need to reference the volume snapshots. And you can see they're already ready to use. And our persistent volume claim is bound, so it should be up and running. And our pods are up. And our website is back. And then that's the end. Yeah.
Awesome. Thanks, Nolan. So great. We saw that we can use the volume snapshot APIs and the volume snapshot contents APIs to successfully restore stateful applications. So what does the future of CSI look like? Well, clearly one area that we kind of see growing, especially as Kubernetes moves to moving current storage providers out of tree and migrating to CSI, is more CSI drivers with snapshot capabilities. Additionally, we need to take the snapshot CSI APIs that are currently there and bring them to GA. So we just released beta, but we need to keep iterating on those and bring them to GA. And then there's also all this great ecosystem tooling that, again, can build on top of those APIs, for example, like the Velero CSI plugin, and improve the workflow in certain areas. So things like what Nolan pointed out there about having to copy around that snapshot handle, that's something that we can improve on in ecosystem by just improving that workflow. Other things that are going on in the community around CSI and volume snapshotting, one is the execution hook KEP and API. And this is all about enabling application quiescing and unquiescing. So in order to take application-consistent snapshots, we need a way to run a command in containers in pods in order to quiesce and unquiesce state before taking a snapshot. Another KEP that's worth mentioning here is the stateful application data management KEP. And this is all about taking application-level snapshots. So we kind of looked at the volume snapshot and volume snapshot content APIs, and these kind of deal with volumes specifically. But if we're interested in taking a full application backup, we want to have higher-level APIs to look at that from an application point of view. So where to contribute if you're interested in this? SIG storage is obviously a great place to get involved in. Since we're all at KubeCon, there's a SIG storage intro and deep dive that's happening tomorrow at 2:25 p.m., so please do attend that if you can. Otherwise, SIG storage meets every Thursday at 9 a.m. Pacific time, bi-weekly. And there's also the SIG storage Slack channel, as well as the mailing list and GitHub that you can also get involved in. And then CSI also has its own Slack channel, which is CSI on Slack. And then there's also the GitHub repos for CSI specifically as well. As Nolan mentioned, the demo materials that we use today are all on GitHub in this repository. So, and again, the slides, you can download them from sked.com. So you can find these links in the slide deck. Thanks a lot.
Questions?
Is what you guys demoed also possible for where you get rid of the, I forget which one it was, but the cluster level resource if you had existing snapshots in AWS CBS, for example?
Yeah, so one thing that didn't quite make the cut for the demo is there's what is kind of called in the CSI world an import. So you can create a volume snapshot content with the snapshot handle already populated, already pointing to an existing snapshot in your provider. So let's say I made a snapshot in my web UI and it's already there, and I want to use it. Or say I made one with Velero and I want to move to CSI. You can do that. You would apply the YAML for your volume snapshot content and create an associated volume snapshot with it. There's it wasn't in our slides here, but there's a blog post that details how to do that with the alpha APIs. I don't know about with the beta APIs at the moment.
Hi, is it possible to run this on a scheduled frequency basis and then have a delta backup on the snapshots model?
I'm sorry, could you repeat the question?
So, for example, like we did once, and it is stored as a snapshot on a storage provider, right? So, is it possible to run on a frequency and then have a delta after the first snapshot? Like just pick the delta data and then append on the snapshots, keep on appending like a backup mechanism.
So, like incremental?
Right, yeah.
I don't believe so at the moment.
Yeah, I don't think that's possible today, but it's certainly something that SIG storage is, actually, I think we discussed it at the SIG storage face-to-face earlier this week. So it's definitely something that we're thinking about.
So one question regarding the application hook API for quiescing the application. I don't know if it's been considered, otherwise I would suggest that there is possibility for this application quiescing command to return, obviously, the status, successful or unsuccessful, whatever, but also maybe some extra metadata, which, I don't know, could be standard output or something. Could be very interesting to label some data about the snapshot itself, the quiescing process.
Yeah, that's a good point, and definitely get involved in that, Kev, and I'd love to talk to you about that afterwards as well.
Does this system address anything around like consistency, whether it be like file level consistency or whole volume level consistency when you're doing the snapshots?
So I think that really depends on the provider. And Jing, you might correct me if I'm wrong, but it's it really depends on what the provider's implemented in their driver. Do you want the mic? German, could you bring in the mic up here?
So for consistency group, we are actually working on that in SIG storage. There is a Google Doc where we are designing this feature. So we have not really reached the consensus yet, but you are welcome to join the discussion. And there was also another thing that Adnan mentioned earlier on. There was the application snapshot. So that one will be doing this application level consistency. Does that answer your question?
Yeah. Thank you.
Okay.
Thank you, Jing.
Yeah, if there are no more questions, then thank you again for giving that great talk.
Thank you.
Thanks a lot.